Okay, then moving on to this example here, we have a plane, so we'll make a plane, and in vectors, visualization is so important in these problems. And so I have a perpendicular vector here, it's perpendicular, and this is 1, minus 1, minus 2. And it passes through some point here, and that point is negative 1, 2, 5. And I want to find the vector equation of the plane in scalar product form. Well, I know that a unit vector times the general vector r is equal to d specifically. But I'm going to just, at this point, I'm going to just make this any vector, not a unit vector. I'm going to make it a perpendicular vector dot x, y, z is equal to some value d. I don't know what d is, and I do know that this is not a unit vector, but it is perpendicular, so it will vary the magnitude of d. This d will not be the distance away from the origin. If I want to find what this d is, I can just plug in my point into my general point. And so when I do that, I end up doing 1 minus 1 minus 2 dot negative 1, 2, 5, which is negative 1, negative 2, and negative 10, which is our d value, which is negative 13. And so 1, negative 1, negative 2 dot x, y, z equal to negative 13. This is a scalar product form. Okay, this is scalar product form. Scalar product form. However, that's a part finished. If I want to find the unit vector perpendicular to the plane, well, if I want to find the unit vector, I'm going to take my normal and find the magnitude. And so the magnitude of that vector is going to be 1 squared plus negative 1 squared plus negative 2 squared, which is 1 plus 1 plus 4 is square root of 6. So if I want to find this, if I want to find a unit vector perpendicular to the plane, that's going to be 1 over root 6 times 1, negative 1, negative 2. This here is my unit vector perpendicular to the plane. C part then says, find the distance to the origin. Well, to do that, I have my scalar product form. And with this scalar product form, I'm going to take it, and I know if this is a unit vector, then d here is the distance away from the origin. So I'm going to take this equation, and I'm going to multiply it by 1 over root 6. So it's 1 over root 6 times 1, negative 1, negative 2, so negative 2, dot x, y, z equal. If I multiply the left-hand side of the equation by 1 over root 6, I must multiply the right-hand form of the equation. And so now what I've determined is that this is the distance to origin. Okay? Because this is a unit vector. So that's how we can use the unit vector and the distance to the origin. And the final question says, find the Cartesian equation of this plane. Well, to do that, I'm going to start from the scalar product form here. I'm going to take that form, and let's work from there. And this is the key. We take our scalar product form, and we actually just multiply it out. And so if I multiply out the scalar product form, I get x minus y minus 2z is equal to negative 13. This is what we call Cartesian. This is the Cartesian form. Let's try another example. This one's about the Cartesian equation of a plane. Actually, I'm going to stop it there and introduce